Hi, everyone, and great that you joined this session. My name is Yatka, and I will run this workshop with you. The workshop is about data visualization using the Snap visual programming language. And maybe we'll wait for one more minute until everybody's logged in, and then we start the session. Yesterday, everybody shared where they're from, so maybe you want to do that too in the chat while we get everything started. Okie dokie. So let me share my screen. And hi, by the way, hi from, I'm originally from Germany, but currently in South Africa. So hi from South Africa, and we'll be sharing the code at the end of the session. So let me start sharing my screen. What I want to do with you today is work in a visual programming language that's called Snap. This is actually a programming language that I'm helping to develop. So for those of you who know Scratch, it might be familiar with you. And this is also an active programming workshop. So I highly encourage you to get your computers out and also follow along. I will for each of the projects that I want to show you today, I prepared a link. So you'll be able to show or to see the projects in the link. And then you can follow along with what I do. But let me give you a quick overview about what Snap actually is. So Snap is a visual programming language like Scratch. And it looks like the Scratch development environment too. So on the left side here, you can see all the blocks that you can use, and the blocks usually have something written on them, and that's what they do. So if I click on the Move 10 Steps block, you see that the small object, which we call a sprite, is moving. So whenever I click on the Move 10 Steps block, it'll move 10 pixels on the stage. If I click on the Turn block here, it'll turn. So you can actually see that all the blocks work live. So whenever you use them in the palette here on the left side, you can just try out what they do. If you want to attach them to larger scripts, you can use the central area that we call the scripting area. So in the scripting area, you can put together blocks to larger scripts. So for example, if you wanted to program a square, you could move 100 steps, turn 90 degrees, and then repeat the whole thing 4 times. If you actually wanted to see it, this is how you could do that. So the scripting area lets you assemble the blocks to larger scripts. And here on the right side, you have the stage. And on the stage, everything that you program happens. And here on the bottom, we have what we call the sprite corral. So in the sprite corral, you see all the objects that you have right now. You can have as many of them as you want. And all of them have individual scripting areas. So this was my original one. This is this yellow one. So you can have as many sprites as you want. In this workshop, I want to take a look at data visualization with you. So everybody keeps telling me, and probably you too, that data is the new big thing that everybody needs and can gather information from. So I thought, why not make a workshop about visualizing different kinds of data. And for that, I prepared 4.5 projects. So one is an excursus if we still have time. And as I said, I'd urge you to follow along because this is a more interactive and more fun experience if everybody programs it together. I suggest that I always share the link in the chat. So this is the link of the first project, and then I'll upload when you click on that link, you get to my version of the project, and you can keep working along with what I do, but in the end, I'll save everything to my project, so you'll always have the final project available. And the first project that I want to do with you is actually one that works with photos. So when you think of data, you can get different kinds of data. Usually it's like a database with numbers or a table that contains texts, or it could also be photos. So the first project I want to do with you is what we call the time lens. So this project is it contains 2 photos of the Northwestern Glacier. You can see the photos if you open the project and click on the link that I just posted to the chat. You can see both photos if you click on the Costumes tab here. And then you can switch between the 2 photos. This one is the Northwestern Glacier at the beginning of the 2000s. This one is the Northwestern Glacier at the beginning of the 1900s. And you can already see that here it is a color photo, but you can also see that parts of the glacier are missing. So glacier melting is a thing. The Northwestern Glacier, by the way, is located here. So it's a very big glacier in Alaska. So this is where we are in the world. This is Alaska. This is where the Northwestern Glacier is. And this is where I got the 2 photos. So now in this first project that I want to do with you, we want to create a lens that lets us look back through time and see what the glacier at a specific position looked like at like 100 years ago. So for that, as a first step, we'll create a new sprite. To create a new sprite for the lens, you can click on this add a new turtle sprite button, and you'll get, as before, you get one of these arrow-headed things. As a first step, we want to draw a costume that resembles a lens roughly, so something that's overly shaped or round. And you can create a costume for an object by selecting or clicking on the Costumes tab up here, and then selecting this paintbrush. So this will open a costume editor, and you can draw something that resembles the shape of a lens. So for example, I want my lens to look like this. And then you can press OK, and you see that the object changes its shape from the arrowhead that it had before to this roundish thing that it'll be now. Also, you see that you can automatically drag around the sprite with my mouse pointer. I don't want to do that because we only want to drag it around programmatically by the script that we'll just create in a second. So as a next step, we have to click here on this draggable button and remove the check mark. So now I can't drag my sprite around anymore. Let me save the project. And now again, when you just so you see how this will be working, I'll post the link to the chat again. And whenever you click on that link now, it will contain my lens here as well that you can't drag around anymore, and the second object that I created. So now we need to create a script that lets us actually drag the lens around on the stage. To do that, we need to find out how we want to trigger that script. So I'd suggest whenever we click the mouse, so whenever we press the mouse button down, then we want to start the motion. And when we release the mouse again, then we'll stop moving. So the rough construct is when I am pressed in this case means the mouse goes down. Careful, there's also when I'm clicked option. Clicked means that the mouse goes down and up again. So then you can't move anymore with the mouse pointer because the whole click is already done. So in this case, we want the when I am pressed option, and then we want to do something until the mouse is not down anymore. So this is our rough structure. We start when pressing the mouse pointer, and you see that the script now highlighted. So I click again, and then you should see this like greenish shadow around the script. That means that it's active. So I have my mouse pressed right now, and when I release it again, it stops being active. So now we can let it do something. For example, follow the mouse pointer. For that, we can go to the motion category. By the way, you can see that all these blocks have different colors, and that's because they come from different categories. So all the yellow blocks are in the yellow control category, all the green blocks are in the green operators category, and all the bright blue blocks were in the sensing category. And now I want to do something that has to do with motion of the sprite. So I want to let it go to my mouse pointer, and whoop. And that means that we go to the motion category, and then we can grab the go to mouse pointer block. And when we have that, we can click on the sprite and can drag it around now again. So let me again save my version of the project. If you follow along, that's great. If you didn't manage to follow along yet, then you can start working in my project again. In the Q&A session or section, somebody asked whether Snap is better than Scratch. I wouldn't necessarily say that. It's just a different approach. So the Scratch is aimed at young learners, and the Scratch team wants everyone to be able to explore the language themselves. So they want all concepts to be discoverable. That's amazing, but of course has the offset that like some concepts are just a little too complicated to grasp for yourself. So the Scratch team just decided to leave them out of the programming language. And this is where Snap comes in. We develop Snap together with UC Berkeley. So I work for a software company, SAP, and we do that in a joint project with UC Berkeley, and it's basically an advanced version of Scratch. So we want to make university level, high school level programming content, programming concepts with a blocks-based programming language, but I wouldn't necessarily say that one is better than the other. It's just a different target group. So Scratch is targeted at younger learners who individually explore the programming language, and Snap is more targeted towards older learners that want to use Snap in a curriculum or at least like in a supported way. Okay, so now we can move our object around with the mouse pointer, but we can't see what's on the what happens 100 years back. So we now need to switch to the canvas object. So we have these two objects, the sprite that I just created. By the way, you can also rename sprites up here. So I could rename it to lens. And I also have the canvas sprite, and this is where the photos are in. And now we have this idea that we call cropping. So we can actually display parts of a photo on another object. That's also something that you can do in most graphics design softwares, and in PowerPoint, for example, it works too. So you can display part of an image on another shape, and that's the idea of like cropping a shape or cropping an image to a specific shape. And we can do that by using the paste on block. So you can find the paste on block in the pen category, and you can select where you want to paste the photo that you're currently in, or the object that you're currently in, on. In this case, I want to paste my photo on the lens. If I click on it now, so before you do that, make sure you know where the lens is, because if you click on it, it'll now look like the photo in the background because you just pasted everything on the lens. So now I have my my photo pasted on my object, but what I actually wanted was the 100 years back photo. So before I paste, I need to switch to the other photo. So in the looks category, you can find the next costume block. Because we only have two costumes, we can just always switch between them. So before we paste on the lens, we want to switch to the next costume. And then afterwards, we want to switch to the next costume again. So now if we do it like that, we can move our object somewhere, can click on the script, the next costume, paste on lens, next costume script, and then we can show how the image looked 100 years back at that position. So here, for example, we can see that the water was farther like back in the sea, and that's obviously because a lot of water was bound in the glacier. So the glacier used to be here, and here you can see like big masses of water are bound in the glacier, and that's why the water, like the water is way farther out here because all the glacier is gone today. So you can already discover a couple of things about climate change here in this very simple thing. Okay, so now it'll be cool if we could automatically trigger that reaction. So let me save the project again. And if you click on the link in the chat now, you should be able to see the current version of the project. And then it'll be cool if we could automatically switch between the switch between the photos. And we can do that by adding a head block here on top. So let me go back to the lens sprite, and you can do that too. And let me actually broadcast a message. So the concept of broadcasting is is a concept that's also present in Scratch. And the idea is that you can send messages throughout the whole project and then you can react to it. So all sprites can react to it, but also all scripts in a sprite can react to it. And you can broadcast a message by clicking on the drop-down menu here. And either if you already have messages, they'll be shown up here. And if you don't have any messages yet, you can click on the new option here and then just write a message down. So in my case, maybe I'll call the message update because I always want to update the photo. And now I want to broadcast this message whenever I went to a new position. So right now, nothing changes because I'm not reacting to the message, but you see the script is highlighted. So whenever I'm going to the mouse pointer afterwards, I'm sending the message throughout the whole project. And then we can go back to the canvas sprite and react to that message with the when I receive hat blocks. Hat blocks are differently shaped than the other blocks that we used so far. So you can see that we have these puzzle piece shaped blocks that we can stack together in a way that we want, like in any way that we want. But in the hat blocks, they have this like wavy structure on top. So that means you can only attach blocks at the bottom of them. And whenever what's written on the hat block happens, then the script below that hat block is triggered. So for example, in this case, whenever we receive the update message that we're sending when we move the lens, then it'll go into switch to the next costume, pasting on the lens and then switching back. So now I can just drag my object around and can see how it looked 100 years back all the time. And here you can see what we kind of already knew or saw before. There was a pretty big glacier, so this is all ice and it's all gone today, but that's why we have so much water down here. No ice anymore. By the way, there's an interesting fact. So melting glaciers are actually pretty problematic because on the one hand side, there's a lot of water. So we have rising water levels in the sea, which is problematic for some regions where people live very close to the ocean. That's really problematic. But on the other hand, there's what we call a positive feedback loop. So actually, climate change increases if glaciers are melting because there's this effect that's called the albedo. So albedo is how much light you can reflect. And ice, since it's white, can actually reflect a lot of light. So that means it's actually a positive thing against climate change because it's reflecting a lot of sunlight. And if the ice masses that we lose right now with all the glaciers are gone, actually also this reflection albedo effect will be gone. So we'll even trap more heat in our atmosphere, which is kind of problematic. Okay, wait, let me try the link again. If not, I need to share the product. Oh, no, it should work. So if you click on the link, it should work. Maybe just try to refresh it again if it doesn't work for you, because it's an open project. You should be able to just use it. Maybe let me check in an incognito window just to be sure. But I think the project is shared for everyone. Yeah, okay. So try clicking the link again. The project should work. Okay, so now again, let me save this last version. And then there's one last thing that we can actually do, because when I move my object out here, you can see that it still contains, like down here, the parts of the other photos that I stamped on it before, because my photo doesn't go like right to the edge of the stage. So what we can do to avoid that is we can just switch to the original costume before we paste on the new one. So now when I move it out, I'm getting the black costume. We could even just like make another one in white. Maybe that looks better then. So now I'm switching to Untitled 2. Whenever I do that, now you see that when I move the object out of the stage or out of the photo on the stage, that I can't see it anymore. One more thing, be careful, like you can totally drag the object out of the stage and then you can't get it back in anymore. So if that happens to you, you can always get stuff back by moving it to the center of the stage, or by just clicking on go to X0, Y0, then you'll get it back, just in case you accidentally drag your sprite out of the stage. Okay. So this is the first project. Let me upload it, and then let me show you one last thing in this project before we go on to the next project. As I said, this works with, if you click the link again, this is now the final version of the project. So that one should work for you, and you can open it and can try it out. As I said, this project only works with photos. And in this case, of course, it's also really important that the photos are recorded at the same time, at the same place in different times, because if the photo is like slightly off, the whole thing doesn't work. Then you have to compare them hand by hand. But there's other visualizations, like from different lakes, where you can see like the Aral See, for example, or Lake Victoria, where we have water levels going down and the lakes are drying out, where you can do these comparisons. And you can also do it with your face, for example. So in the costumes tab, let me delete these two right now, and let me actually record two images with my webcam. You can do the same thing also with your face and two different photos. So this is also a fun project, just if you don't want to visualize any actual data, but just want to have fun with the project. But let me not save this right now, because this is not the original version of the project. So let me just reload it. But if you want to try it out, again, you can go to the costumes tab, and you can just wait in the canvas object, of course, and you can just import new costumes with the webcam and take pictures with the camera. So if you do that for the first time, you actually have to allow Snap to access your webcam. This is only valid for the Snap website, not for the general settings of your browser. But if you don't want that, you can also revoke the like that Snap can access your browser afterwards. Okie dokie. Then I'll give you one more minute to explore the project, and then we can go on with the next project, because we don't always have photos available where we can compare things. Sometimes we want to combine photos with data, and I have a second project that's based on a campaign of the WWF Japan that tries to visualize the loss of biodiversity in like animals. So if you're done trying out this project, we can go on to the next one. Okie dokie. For the next project, we're going to work in this one. Maybe you can try it out right away, whether you can open it, and if not, let me know. So the next project that we're going to try is called Population by Pixel, and it's actually a creative data visualization. And I like it a lot, but it also has a couple of problems that we can discuss later. So this is the idea that it's based on. So this is the website of the one award. So this is a very like renowned award in design, and this was the campaign that won the award, and it's called Population by Pixel. And as I said, it's an idea of the WWF Japan, and they try to visualize animal species with as many, so photos of animal species with as many pixels as there are individuals left of that animal. So I assume this is in gorilla, and here they write down 325 is not enough. So this is a gorilla displayed in 325 pixels. Then we have a panda, 1600 is not enough. That's some kind of bird, and I don't even know which one. So the idea is that we represent animals with as many pixels as there's individuals left in the species. And what I really like about this project is that the message that you can literally see them like getting unclear in front of your eyes because they are so pixelated. And I like that. So I tried to recreate the project in Snap, and we're going to do that in a second. I gathered data from the IUCN website. So the IUCN Red List is an organization that assess animals or animal species for whether they're endangered or not. So they classify species in these, I think it's 9 categories. So data deficient means that there's not enough information that we can actually make an assessment. Then least concern is everything is fine with that species. We have the near threatened and the vulnerable categories where the animals are like slightly endangered, but it's still okay, but we have to look at it. And that's true for both vulnerable and the near threatened categories. And then we have the ones that are seriously endangered. So there's the endangered categories and the critically endangered categories. And today in the project, we're only going to look at animal species that are in the critically endangered group. And then we have the ones that are actually extinct already. So there's a category of extinct in the wild. That means that there's still individuals left in like zoos or other safari parks or something like that, but not in the wild. And then extinct just means they're gone. And the last category is not evaluated, but that means we haven't not looked at, or they haven't looked at it yet. To assess whether a species is endangered or critically endangered, they look at the global like distribution of the species, so where their habitats are, and then the amount of individuals that we have of that species and the trends that we can see currently. So whether they are like decreasing or increasing. So if you're individuals, or if the population trend is decreasing and you have a very low individual number, then you're probably in an endangered or critically endangered state. I put that down in a link for you. So if you want to check it out later, you can totally do that. But this is the project that I want to work with you, that I want to work in with you now. And as you can see, I collected a couple of species here. For example, the leopard or the North Atlantic right whale, the tiger, the Asian elephant, the eastern gorilla, the giant ibis, the slender-snouted crocodile, and the axolotl. Maybe, so you can see how it actually works. Let me just go back to the IUCN website and we can look for one of these animals. So for example, let's do the leopard. And then when it loads, we can look for the mammal. Panthera pardus is the Latin name of the leopard. And then you can check. So here they see the population trend is decreasing. This is the habitat. So they have a very, very big habitat actually. But you see that red means extinct. So it's extinct in a lot of areas already. The yellow ones are the ones where it still lives. And then you can try to find out information about the population trends. So here they don't give you the number of mature individuals because we don't really know. So I looked at the population in detail, and you can see that we have different subspecies of the leopard. So that's Panthera pardus orientalis, and here that one's critically endangered, but we don't know anything about it. Then we have this North Chinese population, and they tell us that it's about 100, like about 200 to 350. We have different other subspecies, and the Indian leopard is the one that's actually least endangered with over 15,000. But that means if you look at my number here, the 18,000 leopards that I counted are all of the subspecies, so they wouldn't necessarily meet. And then we can, for example, look at the North Atlantic right whale. My North Atlantic right whale has 250 individuals. So for some species, let me type the North Atlantic right whale in here. They have very good individual numbers. So here they just let you know it's 200 to 250,000, 200 to 250. And that's because we know pretty well where the whales are. They migrate every summer and every winter. So in the summer, they migrate from like here, the Caribbean and North America to, no, in the winter, they are here in North America and the Caribbean. And in summer, they migrate up towards Greenland. So there's a lot of people along the way who are all the time watching and counting the animals. So here we have a pretty good knowledge of how many individuals we still have present. And 250 is not a lot. So this is really, really bad. The North Atlantic right whale is very critically endangered. And you see that the population trend is still decreasing. So for a couple of whales, the population trend, like humpbacks, has gone better the past recent years, but for the North Atlantic right whale, it's still pretty bad. But this is how I gathered the data that we have in here. So it's not a lot of species, just a couple of them. And now we can start working with them. So again, now you can all open the project, share the link in the chat, and we can try out a couple of things. So here we have I have a couple of like exercises that you can just do. So for example, the first one is use the arrow key to scroll through the photos. So here you can see what photos we have. This one is the elephant. This one is the eastern gorilla, then the giant ibis, the slender snouted crocodile. This is an axolotl. This is the leopard, the North Atlantic right whale, and the tiger again. So you can scroll through all the photos. And once you did that, you can actually make them transparent. So you see that I have the photos in this other sprite that I call the background sprite. And the background sprite contains the scripts for moving the photo. So when you press the right arrow key, it'll switch to the next costume and broadcast update. And when you press the left arrow, it'll switch to the previous costume. So this is the costume number -1, so the previous costume that I was wearing, and it'll broadcast update again. And this one just makes the photo transparent when you click the green flag. So when I click the green flag, my photo will be transparent, but it's still here in the background. And now we can start doing things. In this project, we want to recreate the photo with the amount of pixels that we have as individuals. So we start by maybe just drawing dots on the stage so we know how we can make a pixel. And I already prepared the blocks for you here. So to create one dot, you need to put the pen down, then you need to move 0 steps, and you need to put the pen up, again. If you click on that script, not much happens, but if you move away the sprite, you see that you got this teeny tiny dot here in the middle of the stage. I can try it again. I click, and then I move the object, and now I have another very small dot here that more looks like dirt on my screen. But anyway, it's actual dots. But to make them bigger so we can see them, we can just increase the pen size or set the pen size to something bigger. So let's start by setting the pen size to 10 maybe. So click on it once that it actually does it. And then you can click here again and you can see that you get a 10 pixel wide dot. Okay, please all try that out to create one dot, increase the pen size, and then create a couple of them. If you want to clear the stage again, you can just click on the clear block that I already prepared here for you. So clear clears everything that you've drawn on the stage. Once you tried out the dots, we can try to draw them in an organized fashion. So for that, I prepared the grid block for you. So this is not a regular block in Snap, it's in a library. And you can see how it's made. It's kind of complicated, but no worries, you can just use it. And the grid block just does whatever you tell it in this C-shaped input slot as often as like you indicate here. So for example, I could draw a grid of 10 by 10 dots. So I know that this script draws the dots. So if I do it like that, I'm getting 10 dots, like 10 rows, and then 10 columns and 10 rows. If I type in 20 in here, I'm getting double. 40 in here, I'm getting double. So you see that you can just indicate how many rows and columns you want. This works because the stage in this project is a square, so that it's easier to calculate, but it'll just draw as many rows and columns as you indicate in here. And if you tried that out, you can just put it together to one script and try out different grids. Okay. This is already pretty cool, but we can't see the image so far. So as a next step, before we actually start calculating stuff with the number of individuals, we want to show the image already. So for that, we have these two blocks. So you can, right now, our pen is drawing in black. I could set another color. So for example, I could set the pen hue, saturation, and brightness to some values. Maybe let me just open a new project to explain. Don't do that. Just watch what I'm doing. Let me explain the how the pen in Snap works. So on computers, there's different ways on how you can represent colors. One that you usually know from photos is the RGB color model, where you have a pixel with 3 color channels, the red, green, and blue channel, and they contain values between 0 and 255. That's very good for computers, but very hard for humans to understand. So if you want to build a specific, if you want to make a specific color, it's kind of hard to find the right numbers for a very specific color. So in graphics design software, we have other color models, and some that are very frequently used are the HSL and HSV color model. And in Snap, we use the HSV color model in the pen. HSV stands for hue, saturation, and value. But since value doesn't really mean anything, we renamed it to brightness here. And let me increase the pen size for the size here first. So you can, now let's even do 300 so you can actually see what I'm doing. So now let me set all the components to 100. So I'm setting the hue to 100. I'm setting the saturation to 100, and I'm setting the brightness to 100. And if those are the maximum values here. And if I do that, I'm getting this very bright red color. And now let's try what happens when we cycle through different hues. So let me repeat maybe 200 times, move one step, and then change the hue by 0.5. And so that we actually can see what's happening, we put the pen down before and we put the pen up afterwards, and we set the pen size to 30. So if I do that now, I'm getting a line 200 length with all the different color values that we have. So here in the middle, for example, that's a hue of 50. That's where we have this teal color, 60, 70-ish is blue, 80-ish is pink. And then if we get to 100, we're getting the original red color that we had before. So the hue changes like where on the rainbow we are with values between 0 and 100. Now let's take a look at the second color component. That's the saturation. So if I set the saturation to 0 and leave the other values at 100, so at their maximum, and then I change the saturation by 0.5 each time. When I have the saturation at 0, but the brightness at 100, I'm getting white. So the saturation actually regulates how much or how intense the colors that we get. So the color intensity, so how much of the actual hue is in the final color. And then if we cycle through all the saturations, you see that we start by very pale colors and we end up by very bright red again. So that's the intensity of the color. And the last one is actually the amount of light that we have in our color. So if my brightness is 0, I'm having 0 light in my color. That means that it's black. But then with increasing the brightness, I'm getting back to the original bright red color that I had. Okay, so now that we know how the color system works, we can go back and take a look at the population project that we had, because now we want at each position that we're at, so in each of our cells in our grid, we want to actually measure the hue, the saturation, and the brightness that we have there. We can do that by using the hue at myself block. So let me clear and let me take the object back to the middle, which is probably on the nose of the tiger. So if I click here, I'm expecting a color that's very, yeah, I think brown is probably yellow reddish. So something that's close to 0, 16.6. Yeah, that kind of works. And if I check for the brightness, it's not super bright, but it's also not super dark. So it's somewhere in the middle. And I can check the saturation. So it's really lowly like saturated at that position. So I can find out all the color components at the position that the sprite is currently at, which is right now the middle of the stage. And then I can set the color respectively. So I can set the hue to the hue at that position. And then I can set the saturation to the saturation at that position. And if you're following along, be careful. You have to select between the saturation at the mouse pointer and the saturation at myself being the object that's currently programmed. So saturation at myself is the one that we need. That's at the current position of the object. And then finally, we need to set the pen brightness to the brightness at myself. And if I do that right now and click, then you see that I'm currently at the somewhere here, probably on the eye of the tiger, where on top of the eye of the tiger, where it's gray. Let me move this. Here it's still gray, but a different kind of gray. Here it's brown. So maybe let's switch to another picture. The elephant, if I move it down here, I'm expecting something more green. Yeah, here's a very dark green. Here's a brighter green. Here in the middle, I'm expecting gray again. So now I can move my object around and I can change the color accordingly. So if we want to use that now to redraw the photo, we can just add this script. So setting the pen hue to the hue that we're measuring, setting the saturation to the saturation that we're measuring, and the brightness to the brightness. We can just add that on top before we draw the dot. So inside the grid, but before we draw something. And if we do that now, we kind of get the elephant. So let's increase that. So you can see that this is a redrawn version of the elephant. Now we can switch to another photo. It also works with the gorilla. It works with the ibis, crocodile, so it works for all of them. Great. So this, let me save this project so that you all have this version now. And if you open the project now again, you'll have my version. And now what we need to do is somehow factor the individuals in that we have. So here in our critically endangered species variable with the list, we have all the numbers, but we now need to use them. Since this is this is a mathy exercise for a second. This is a square photo. So to find out how many rows and columns we need in our grid, we can just take the square root of the number of individuals that we have, because if we square that again, we're getting the right number of pixels. That's why I made the photo quadratic, like squared, so that it's easier for us to calculate. So we first need to find out, and let's do it for the, I'm in the axolotl photo right now. So maybe let's just try it for the axolotl. Axolotl is item 8 in our list. So if I'm selecting item 8 of my critically endangered species, I'm getting the entry axolotl 1000. Now I need to access the number. So I need to get item 2 of this to actually get the values for the axolotl. So item 2 of item 8 of the critically endangered species variable is the number of individuals for the axolotl. And we can now take the square root of that to find the number of rows and columns that we need. Since we can't draw 31.6 columns, we're going to be a couple of pixels off, but I think that's fine. So we'll just round this. And then since we want to reuse that value, we're going to set a variable so that it also doesn't look so confusing. I already prepared a variable for you. This is the columns and rows variable. So let me select the columns and rows, and then we can just set what we just calculated to the columns and rows. And now if we show this variable, we know that for the axolotl, we're going to get 32 rows and 32 columns to draw it properly. So we can now just add that on top. And we now have the right amount of rows and columns for the axolotl. To adjust our script, because now we're still drawing 40, to adjust our script, we can take the columns and rows variable from here, from the variables category, and just drag this orange blob that's named columns and rows into the grid block. So now I'm adjusting for the value of the axolotl. And I have 32 columns and rows. Let's switch to another one. So this is the leopard. The leopard, I think, is item 1 in our list. So to get the current values for the leopard, I have to look for item 1 here. And then I'm picking item 1 of item 2. So this is the 18,000 individuals for the leopard. And if I click on it now, you see that I'm getting the leopard. But for the leopard, my size of the dots is much too big. So we need to adjust the size of the dots that we're drawing. Right now, I'm always drawing in pen size 10, but I want a different pen size based on whatever animal I'm getting. So we also need a second value that calculates the correct pen size for each of the individuals. And we can do that. Oh, wait, let me just remove this. We can do that by using the blocks down here. So to calculate the correct pen size, when you think of it, we know how many rows and columns we have on the stage, and we know how wide the stage is. So to get the maximum size, we just divide the width of the stage, which is currently 512, by the number of columns that we have on the stage. You could also do the height of the stage by the number of rows. That's the same since it's a square. And if we divide the width of the stage by the number of columns and rows, we now get the correct pen size for the leopard. So if I click on that, I see that instead of the 10 that I'm having right now, I should rather have the 3.8 for my leopard. And we can use that in the size variable and then set the pen size to the size. So you can snap these two together, and then we can attach them at the top of our script. In this case, it's important where you put it, because you're using the columns and rows that you set, like the variable of columns and rows. So you need to make sure that you first set the columns and rows, and then afterwards set the size, so you have the correct value for columns and rows before you set the pen size. So you can attach that like right after you set the columns and rows. And if you click on it again, you now get the leopard, but with the right amount of pixels. So this is our image for the leopard with the amount of pixels that the leopard requires. Let me save this. And now if you open the project again, once it's uploaded, you can try this out. Maybe I'll give you like a minute to try this out, and then we can finish the project. Okay, apparently it seems to work for everyone, or at least nobody's complaining. So let's go on, because now there's like 1 or 2 small things that we still need to do. I don't want to manually check which photo I'm currently using and then adapting the numbers in here, but I rather want to do that automatically every time. So we have to find out which costume we're currently wearing, and to prepare this, the number of costumes, or the order of the costumes matches the order of the animals in our animals list. So we can just find out which photo or which costume number we're wearing. So if I'm wearing the North Atlantic right whale, which is the second costume, I also want the values for the second species in here. So that makes it kind of easy. And I already prepared the blocks here for you. We can ask other objects for the specific things. So for example, we can ask the background object for its current costume number. And in this case, it's costume number 2 because it's the right whale. Let me switch a couple of times. So now I'm at the gorilla. That's costume number 5. And you always see that this also matches the number or the species number in our list in here. So we can now, instead of just typing in the number, we can drag this up here and we can just stuff that in where the 2 is right now. So I want the second item of whichever costume I'm wearing. And then I'm picking that right individual. So now when I click on it, this is the one for the gorilla. This is the one for the ibis. This is the one for the crocodile. This is the one for the axolotl. So it now works for all species. And the last thing is, from the backgrounds, we're already sending update whenever we switch to a new costume. So we can use this broadcast to automatically start the drawing process when we switch to a new costume. So whenever I'm clicking on the left or right mouse key, arrow key now on my keyboard, I'm switching to a new costume and I'm drawing the corresponding image. Okay, let me save this because this is the final version of the project. Okay. If you click the link again, you can now try out the final version of the project, and you can use left and right mouse keys, left and right arrow keys on your keyboard to switch between the photos. Or if you don't have a keyboard because you're on a touch device, you can also switch to the backgrounds tab and just click on this right arrow script. That will also trigger the next image. Okay. When you think of this visualization and of the species that we have in here, what do they have in common? I don't know whether you can use the chat, but maybe you can all brainstorm for a second and we can try to find out what these species all have in common and why this visualization is great for the species that we used in here, for the photos that we used in here, but might not work for other ones. Maybe I'll give you all 1 minute to think about it, and then I can tell you what I think if the chat doesn't work. Okay, so the thing that they all have in common is actually like a backbone, a spine. And that's of course not the important thing here, but the bigger species are, and vertebrates are pretty like big usually, the less individuals they have. So the larger species are, the less individuals they have. That's why there's not that many whales. That's why there's not that many elephants. When you compare that, for example, with insects, with worms, with mussels, whatever you could find, we can't show as many pixels on our screen as there are individuals, because if it's millions, they might still be declining, decreasing very rapidly, and it might be super bad, or their situation might look super bad and the trends look horrible, but we can't represent that on our screen because we can't show that many pixels. So this is a very specific visualization that only works for large species that have a rather small area of where they're distributed, so like a rather small habitat, because otherwise it'll just be too many. Like when you think of some European birds, for example, they're present all over Europe and there's millions of them. Still, they are currently declining. Like sparrows, for example, sparrows are significantly declining right now, but there's way too many of them so that we could represent that in this visualization. So often when you see stuff, when you see visualizations, data that have to do with animal conservations, they show rather big species to represent an ecosystem that might not even be that. Not, I don't want to say that they aren't relevant, but for example, when you think of an aquatic ecosystem in an ocean and you look at a whale, they are like right on top of the how do you call it, food pyramid, and there might be things going awry in this ecosystem way before you see it in whales. So for example, when the krill is gone, you might see it in whales, but you might also see it in every other animal species along the food pyramid. So we're not always looking at the species that are the most important for an ecosystem, but rather the ones that we see the best or that are the most important or relatable to us. So that's maybe one more thing about this visualization. Okay, so those were the first two things that I wanted to show you. I suggest that we now do like a 10-minute break and we come back 10 past the hour. So whatever time that is where you are staying, my 10 past 12. And I'll see you back in 13 minutes, and then we can look at one or two more projects using environmental data. Mhm. I didn't say anything yet. That's why you don't hear anything. We're still 1 minute into the break. Okay. So before we start with the next thing, somebody asked in the question and answer session whether there's more learning opportunities like this one when if you want to learn programming, maybe using Snap. I don't have any workshops coming up right now, but what we definitely have is, I mean, we have a forum and everything. We have a yearly conference. So if you are on the Snap website, let me just go to the Snap website. You can create an account there. And that also lets you be part of our forum. So on the forum, you can exchange with other Snap users. And if we have our yearly conference, for example, we announce that there, and then you can participate in the conference if you're interested. It's usually an online conference, so that will work. But we also have a couple of online courses. So for example, this one is a 4-week course that also contains a couple of the projects that I've shown you or will show you today. And then we have a couple of other ones. So this is the from media computation to data science, and we look at a couple of media like photos, and we modify our photos. We look at sounds, we create sound effects, and then in the end, we want to do like a general data science thing where we, for example, learn grouping data, analyzing data, like very basic data science things. Then we have another course that's called Get Coding with Snap. So this is an introductory computer science course that deals with, it's a 2-week course, so that's 11 videos, video lectures, and it introduces like simple computer science ideas like what is a loop, what is conditional programming structures, but also with a couple of fun projects, for example, like games and everything. So if you want to check that out, feel free to. And the last one that was not done by my colleagues and me, but rather by people we work with, it's called Exploring the World of AI, I think. Yeah. So this is a course that looks into artificial intelligence. It was done before the whole Snap ChatGPT hype happened. But if you're interested, I don't know whether there will be recordings of the sessions, but yesterday I gave a workshop about how we explain generative artificial intelligence, or how we try to do that. This one takes a more general look at artificial intelligence, different types of machine learning, like reinforcement learning, supervised learning, unsupervised learning, when you would use them. And it always has an unplugged activity, so something that you could do without a computer, or at least without programming. And then a Snap activity that goes along with the videos. So I can recommend these 3 courses. I like them. And they are free of charge, and you can just take a look at them and try out the things. And then again, if you're interested in more, feel free to participate in the conference or to reach out to us in the forums. We have more activities, and we're all in the Snap forums since we write the programming language. So if you're interested, feel free to reach out to us. Okie dokie. So the third project that I wanted to do with you is the next project that I wanted to do with you is called CO2 on your birthday. So it's based on this data Carbon dioxide data is measured daily at the Mauna Loa. Mauna Loa is a volcano in Hawaii. I think they do it there because it's so far away from everything else, so it doesn't get interrupted by, I don't know, industry that's really close and emits a lot of carbon dioxide. So those are daily measurings, and you can see, I love this website. It's really good. Let me post it to the chat too. I collected a couple of links for you in the drive that I'm going to share later, but maybe if you want to check it out now, I use it for like all my courses that I did in like environmental classes. And you can check the data from the last month, and there you can see that there's daily, so daily oscillations. Night data is different than day data. If you look at the past 6 months, you can't really see anything, but if you look at 1 year, you can see that also during the year, the averages are oscillating in carbon dioxide here too. So you can always see in September, it's rather low here too. And in March, it's rather high. So if you see the full record, they started measuring this data in 1958. You see that we have these yearly oscillations, but you can see that data is going up constantly. So we have carbon dioxide emissions and carbon dioxide concentration in the atmospheres is rising. By the way, if you weren't aware of that, carbon dioxide concentration is measured in ppm. That means parts per million. So if you look at 1 million like molecules in the air, how many of them are carbon dioxide? And in our case, currently, it's like 420-ish, I think. Let's check the 1 week again. So yeah, right now we're at 423. And then you can see the full record. So this is all their measured data, but then we also have more data that we can estimate from, for example, if you look into, you can drill down in like ice, and you can see how the weather, how the temperature, how the climate was there in previous times. So for example, these are not measurements, then like actual measurements from the Mauna Loa anymore, but those are estimates based from other measurements that they made. And you can see that beginning of the 1750s, that's when the Industrial Revolution happened. So when we started using, or 1850s, that's when we actually started using fossil fuels a lot to use like for industry and everything. There you can see that the carbon dioxide emissions start to rise. And this is, again, the measurements that we have right now. If you look at estimations over the past 2,000 years, this is where we are in the measurements. So things are like carbon dioxide emissions and carbon dioxide levels are rising very fast. Feel free to explore this, but I want to do a project with you now that lets you calculate the difference between your birth month and the last month. That's like, so for example, I'm born in July 1998. So I can compare my CO2 level in my birth month with the one from July 2024. So what this is the project that we're working in, link again. So this is a new project that contains all the data and a couple of sprites that I prepared for you. So for example, what we have here is if you click on the green flag, it'll show this button. And if you click on the button, you'll be asked, what year are you born in? So as I said, I'm born in 1998 and I'm born in July. So now, oh, wait. Now I just want to set my birthday. So July, let me do it again. 1998, July. So now I've set my birthday, and my birthday is stored in this birthday variable. And you can do that for your birthday too. Maybe, as I just did now, like make sure that this one isn't attached to the head block already, because this triggers the script for later, which we don't want. But we rather want just the button. So you click on the green flag, select your birthday, and then it's stored in that birthday variable. So now you know your birth year. This is the first entry in the birthday variable, and you know your birth month. That's the second entry in your birthday variable. We also have a couple of data sets. So this is the daily data that we aren't going to use, but I uploaded it anyway. And this is the one that we are going to use. That's the monthly data. So if you switch to the Alonso sprite now, by the way, Alonso is the mascot of Snap. It used to be the original mascot of Scratch back when it was still called Gobo. And then we added this funny hair, which is the lambda hair, lambda calculus, and that's Alonso, our mascot. So anyway, we now have the monthly data. So if you click on this variable and you can double click it here to make it permanent, you can scroll through that. You can increase the size here at the where these three lines are, and then you can scroll through it. So as I said, the official measurement started in 1958 in March. So the first measurement that we had on the Mauna Loa average was 315.70, like 0.7 parts per million. If you check out March 2024, for example, there it was 425. So we saw that it roughly increased by 100 ppm, which is quite a lot. So we can now use that to calculate the differences between our birth month and the last month that was measured in this data set. So for example, we're not having October 2024 yet. I just updated it today. September 2024 was the last data that I could get. And we can now try to do that. So the thing that we want to do is pretty data sciencey now. So this is the most working with data that we have done so far. So this is a bit more of an advanced project. You can just follow along, or I'll just save my project again, and then you can look at my version. It also contains, again, the exercises that we need to go through. So the first one is find the CO2 level for your birth month. And we can drag the functions into the gray ring of the pipe block. So what the pipe block does, it's basically you add a data set here at the beginning or some data. It could also be a number. So in this case, I want to use the monthly data. And if I'm just piping nothing, I'll get the original data set back. But now I could, for example, filter just for my birth year. So that means we only want to keep the data where the first element is the same as the first element in my birthday. So to do that, we can use a block that's called keep. The keep block is a higher order function that takes a condition in here, and I can filter a data set for that condition. So for example, let me show it directly with the monthly. I could filter, don't do that. I'm just giving a, let's do, I'm doing another example. So for example, I could filter from the numbers from 1 to 10. So this is the numbers from 1 to 10. I could filter for those that are even. So for example, I filter for those where the modulo 2 is 0, because that means if I divide them by 2, I don't have a remainder. That means that it's an even number. So this is now a list with all the even numbers. If I'm filtering for wherever the remainder, like of the division by 2 is 1, then I'm getting all the odd numbers. So this is, for example, how you could filter a list of numbers. In our case, we want to filter this monthly list. So let me maybe put it somewhere. And we want to filter it for the first column. So we want to find the numbers or the entries where the first column is the same as the first column in my birth year. So we're looking for an equal sign, but we want item 1 of the entry of our list to equal item 1 of my birthday. Item 1 of my birthday is 1998, and item 1 of my data is this here. So I only want to keep the ones where these match. And then I can drag that into the pipe, and I'm only getting the numbers or the entries with 1998. If your birthday is a different year, which I assume, then you will get different entries. But you just need to make sure that you keep the ones where the item 1 of the entry is the item 1 of your birthday. Okay. Let me save the project. And if you click on the link again now, then you'd be able to open my project. Of course, if you want to use it with your birthday, you need to reset the birth date again, because that's now my birthday. So my birthday is stored in the variable, but if you want to use it with yours, just click the green flag, reset the birthday, and then you can click it again, and that should work. And now we need to find our birth month. So in my case, that's July. So from the data, I only want to keep this one entry where the second item is July. So where the second item is the one of my birthday. So we can add another function that we want to use in our pipe by just clicking the small arrowhead to the right, and then we're getting another one of these great rings. And in these other great ring, we can put our second filtering thing. So now, as I said, we want to keep the items from, and the cool thing about pipe is it uses the original monthly data in the first function, but then it'll use the already filtered, so this list, in the second function. So we can now filter in this data for the one where the second item equals the second item of my birthday. So, and I can put that in here. And now I'm getting only the data for July 1998. I don't even know what this original one was, the decimal. Okay, I don't know. We want the average one. So we're now finally looking for item 4 of that data, because the first column is the year, the second column is the month, then we have this, whatever that is, and then we have the average data. So this is what we want. So to find out what the actual ppm in my birth month was, we need to now report item 4 of that. So this, ooh, hey. Oh, wait, haha, this is another table. So we need to report item 1 of item 4 of item 1, sorry. Okay, so in my birth year, 354.05 was the carbon dioxide levels. If we want, we can also make a variable for that and store it in the variable. So I could make the variable CO2 at birthday. And I can now set my CO2 at birthday variable to all my piped things. And then I have that value. Hey, come on. Oh no, I set my birthday. Oh, I wanted to set that. Okay, now I have to set my birthday again. Sorry. Whoop. 1998, July. Okay, there we go. So now I can set it again. And now we see that the CO2 at my birthday was 354.05. So that's the level that was measured in July 1998. Now we want to calculate the difference. Let me update that again so you can try it with your birthday. And now we can update that again. We want to calculate the difference. So what we need to do next is we need to find all the Julys, like all of my birth months, and we just pick the last one of them. So the last one that's in the data set. So basically we want to do the same thing again. We'll just grab another one of the pipe blocks. You can find the pipe block in the control category. And now I want to pipe monthly again. But what I want to do this time is I want to filter for all the Julys. So in this case, we start with the keep again. But in this case, we want to keep item 2, where item 2 is the same as item 2 of my birthday. So what we had before, but just filtering for Julys right away. So we're keeping the items from the monthly data where the month equals the month of my birthday. So that was where item 2 equals item 2 of my birthday. Okay, now I'm getting a list with all the Julys. So this is July 1958 to July 2023. I thought we have 2024 as well. Let me check. We should have 2024 as well. Okay. Anyway. So this is all our monthly data. And now I can just pick the last July in my list. So if I take item last of that, I'm getting the last July in my data set, which is apparently for some reason July 2023. But anyway, I'll try to fix that in the uploaded project later. So when you access the link again, it should work. So now I have the last measurement. And here again, I want item 4 as well. So let me pick item 4 of that. So this is the carbon dioxide levels in the last July that I have in my data set. And now, wait, let's make a variable for that too. And we call that CO2 last, maybe. And then I'm setting the CO2 last to what I found out here. And now I can calculate the difference between these two. So the amount, the carbon dioxide levels at Mauna Loa have changed since my birthday is just the result of me subtracting the CO2 at my birthday from the CO2 that was last measured. So we can just create, make another variable for the difference. And let's set the difference to CO2 last minus CO2 at my birthday. And now if I click on that, I can see that since my birthday, the CO2 level has changed by 68 parts per million. Sorry, there's a question in the chat, so let me answer this. So here we needed to add the item 4 too. So the result of this one is a table, but a table that just has one entry. The difference between this one here, so this one is a list with 5 elements. This one is a table with 1 element, and that element contains 5 elements. So to actually get to the same status that I was here, I need to pick the first item of that, and then I can pick the 4th item of that to get to the data. And here I can directly pick the 4th item because this one already was a list. I hope that explains the question. If not, let me know. And then somebody asked whether they could use Scratch to do that. So no, the answer is no, because we specifically designed Snap so that we can use it to also do data analysis and do a bit of more advanced data science mathy things that the Scratch team doesn't focus on. So we specifically designed Snap to be able to use these like higher order functions, to use a lot of like math stuff. And the Scratch programming language doesn't let you do that. So no, this kind of project you can only do in Snap. Okay. So now we have the difference, and we have the CO2 at my birthday, and we have the last CO2. And we can now use that to let Alonso say it. So what I had up here before is a script that shows Alonso, and he says things. So now I can enter my results, the results that I calculated. I can enter my results in here. So for example, in your birth month, the CO2 level was, and then I can drag the variable in, CO2 at birthday. And then I can say that for 2 seconds. So for example, in your birth month, the CO2 level was, oh wow, maybe let him say it for 4 seconds. It was 350, 40, 50, oh God, 4. And then I could let him say more things. So for example, since then, the CO2 level has changed by, and then I can drag in the difference, ppm. So for example, now he says in your birth month, the CO2 was 354.05. Since then, the CO2 level has changed by, oh, okay, this is a very weird number. So maybe we'll round this first. before we get the whole thing, before we get him to say the whole thing. Okay, so maybe one last thing, because now I have to click here, we can now maybe make one script. So from the CO2 thing, we're sending the find level. So maybe we'll attach the find level to this one here. So now we're calculating all the values when we're finding the level, and then afterwards we can broadcast another message. So we can broadcast Alonso maybe, and then when Alonso is broadcast or is received, then we want to say this. Okay. Now let me rearrange this so we can actually see everything. Okay, so once more, the process now is you click on the, let me save it so you can follow along. You can click on the button to type in your birthday. So now let's maybe do my mom's birthday. She's born in 1963, December. And now it automatically works with that too. In my mom's birth year, it was 318. And since then it has changed by 104 ppm. And maybe let's try my brother too. My brother's born in 1998 in October. So in my brother's birth year, it was 364.5. And since then it has changed by 54 parts per million. So now this project works for every birthday, because what we're doing is we're saving the values that the user gives us in the birthday variable, and we're using this birthday variable to find the right value in our data set. So we're filtering first for all the entries, for all the elements on our list where the birth year is the same. So we have all month of the original birth year, and then we filter for the birth month. So in this list from the birth year, we look for the one element that where the month is the same than the month in our birthday variable, and then we report the fourth item of that, because that's the actual value that we're looking for. And then we did the same thing, but for the last year. So we for the last month that was reported. So we're filtering for all the, in my case, it was all the Julys. So we looked for every month, every year's July, and then reported that back. And we just took the last one of these because we know that that's the last July in our list. And then again, we reported the actual average value, and we could calculate a difference. So the CO2 last minus the CO2 from my birthday is the actual difference since I was born. And we then let Alonso say that. So this is the final project. Just to be sure, let me save it once more. And that's the carbon dioxide on your birthday project. By the way, we can also kind of easily make maybe let me add this too, like a plot of the data. That works super well. What is kind of hard is making, rearrange this here, is making good axis descriptions and like a legend of what you have. But just plotting the data works really easily. So let me just do that real quick, because we can use a loop that works specifically on list data. So for those of you who have been in the workshop yesterday, already know it. We have the for each loop, and the for each loop lets you do stuff for each element in a list. So we already have a list. Our list is the monthly data, and now we can do something for each item in the monthly data. And the stuff that we want to do is we want to plot the data. So first, we need to make sure that we evenly distribute our data from left to right of the stage. So that means we need to calculate the space between each data point. So the space that we need to move the sprite in X direction, so that all our data points are spaced out evenly. And we can do that by just calculating a step. And the step is the width of the stage divided by the amount of data points that we have in our list. So we're setting the step to the width of the stage. So we can select the stage object and then look for its width. And we divide that by the number of data points. We could find it actually out, but we can also just look for it. So we have 800 data points in here. The first one is the names though, so it's 799. So let me just type it in. That's faster. So we now know how wide or how big the space between each of the data points is. It's 0.6 pixels. And now for each data point, we can let's go to the left of the stage, so negative 240 and then y0. And then for each data point, we want to go to the actual value. Let me do it with the value. And we know that the value that we're looking for is item 4 of each item. So column D, that's the 4th item. So we want to go to item 4 of each item. That's the data, the actual data. That's what we want to plot in y direction. And then in the x direction, we just want to go to the x position that we're currently at, plus the step that we calculated. And then, so we can see what we're actually doing, we have to put the pen down, and then afterwards we can put the pen up again. So if we do it like that, let me actually do it. You see that the script is running, but nothing is happening. The problem is that the top of the stage is plus 180. So the maximum Y position that's visible on the stage is 180, but we know from our data set that the data that we're actually looking at starts at 315. So we kind of need to shift everything down. So before we plot the actual value, we might need to subtract, let's say, 300. And then if we do it like this, you can see that we can plot the actual data, and we can also see the differences between the, ooh, I didn't want that. We can see the differences between the, let me add a clear at the beginning, between summer and winter, or spring and autumn rather. And we can also see that it's increasing constantly. So this is how you would plot data. This is not a very interesting data visualization because it's just like a line, and we're missing, as I said, the axis descriptions, which is really bad in data visualization, but just so you can see, it's very easy to plot this these data. Where it's actually, so let me save the project again one last time. And then let's maybe, since we still have a lot of time, let me just open a new project and let me show you where a visualization like that might actually be fun. So you can now use Snap for the first time in the like plain vanilla Snap version. So this is, if you open Snap, this is what it looks like. And you can just open it by either going to snap.berkeley.edu/run, or you can, if you're already in a Snap project, you can click on the sheet of paper, that's our file menu, and then select new, and this will open a new project with sprite centered in the middle. There is a couple of data that you can easily get from your computer. For example, input from your microphone. You can access your microphone values with a block from the sensing category that's called microphone. So for example, you can find out the volume of the microphone. If you're speaking very silently, it's rather low values. And if we speak louder, it's very like high values. If you scream, it can go up to like 60, 70. So this is something that you could find out about your microphone. Or you could find out the samples, which is kind of interesting. So the samples are values between -1 and 1. And when you think of audio, the samples are, or the samples indicate how far in the left or right direction, so negative and positive values, a membrane swings And by these patterns of the membrane swinging in left and right direction, this is what actually creates the sounds in your ear. So the patterns of these swinging membranes. And we have these membranes, for example, in our ear, or we have them in the speakers or in the microphone. So every time when we use samples, it's the amount or in which direction and amount this membrane swings. And we can, for example, plot these samples. So here you can see them. It's very small values between 0 and -1 and 1. So those are positive values. Sometimes here it's negative values. And the patterns make the actual sounds that we hear. And this is something that we could plot too. So for example, if we want to do this with live data that we get from our microphone, we can also use the for each loop. And we can say for each sample, in the samples of my microphone, I want to do something. Also here, we need to calculate a step first. So the amount that we need to move between each data point. The microphone resolution is 512 data points. So we can calculate the step by, again, dividing the width of the stage by the microphone resolution. So we divide the width of the stage by the resolution of our microphone. And now we can do the exact same thing that we did before. So this is a really cool script because you can use it for plotting like any kind of data. And we want to go to the left of the stage, like -240, and we want y to be around the middle. And then for each sample, we want to be honest, it's actually not 0. Here, it's actually not -240. Actually, you would need to move one step outside of the stage to make it super correct. Maybe let's do that. So we start at -240 minus the step. Now it's correct. And now for each sample, we want to plot the value. And we want to change the x value again by the step. So we're going to the current x value plus the step that we calculated. If I do it like the, and we want to put the pen down, of course, and we want to put the pen up afterwards. If I do it like this, it'll actually take forever. So we want to constantly plot our live data. And to be able to do that, we can wrap warp around it. So warp is Snap doesn't run as fast as it could because we want it to work the same on every person's machine. So we know that kids in school often have not very good computers. Sometimes kids at home don't have very good computers. So we want Snap to work the same on every person's computer. This is why we deliberately make it slower than it could be. If you want it to be as fast as possible, you can add a warp loop around, a warp structure around it. It's not a loop. The thing also is that Snap is a parallel programming language. So if you want to do different things in parallel, warp might ruin that because it doesn't wait anymore for other scripts what they want to do. So if you use the warp, please make sure that you only have one script that you actually want to run, because all the parallelism might get broken by the warp. But if you have that, you can just do everything at once. So let me clear this and let's do it again. And you see that you get the line right away once the microphone actually starts measuring. Look, you have the one line. And now we can do that forever. So we can wrap a forever loop around it. And once the microphone is on, we can actually forever measure and plot the samples of our microphone. What you see here is that it's not really moving because the values in my microphone are just -1 to 1. So -1 is the maximum, -1 is the maximum in the other direction. So we get a maximum difference of 2 pixels. To be actually able to see something, we need to multiply our samples with a value. So for example, we could multiply them with, let's do 120. And now when I run that, we should be able to see my actual microphone input Come on. Hello. Do something. Hello. Okay, let's try this again. Hello. Oh, come on. Why doesn't it work? Okay. This should be working. For some reason, it's not. Let me clear this again. Let's put that in here too. Okay, great. There we go. I forgot to go back to the left side. And we also need to extract the clear here maybe. So now it's working. Awesome. Okay, sorry. What I forgot is to go back to the left side of the stage. So we forever drew this and then we were somewhere out here on the side. But if I do it like that, you can see that I can constantly plot what's happening in my microphone. And you can see while I'm talking that the samples are very like unstructured. If you sing, for example, you see that it's way more regular. And you can also see, sorry, I'm going to sing again, that if you sing with a very high pitch, that the waves are closer together. So that's the frequency of the waves. So higher pitch has a higher frequency, and that means that the waves are smaller and closer together. And also, if I speak very loudly, that's the amplitude, then the sample values are bigger. So if I speak very loudly, the amplitude, which is the height of the curve, is going to increase. So let me try to sing again. I'm sorry. And you see where it's when it's a very low pitch, then the waves are very, very big and very far away from each other. So that's a very low frequency. And when you sing with a very high pitch, that's a very high frequency. So that's an easy way to visualize live information by just plotting it on the stage. You could also now explore different colors, for example. So if you wanted to set the colors each time, you can start with red, and then you can change the hue, for example, for each sample by 1. So if I do it like that, you see that well, maybe let's do 0.3. I'm getting a very colorful line now. We could hide the original sprite so that we don't see it. We just see the line. We can make the line a bit thicker so we can see it better. So we could, for example, set the pen size to 3 instead of 1. Maybe I want it even smaller, just 0.1. I'm unfortunately very, very bad at whistling. It works much better if you whistle, but I'm very bad at whistling. So let me save this project and show you how you can actually save and share projects. So let me save this as microphone visualizer. So this is how you can save projects in the cloud. And then if you go to your project page, come on, load. You can share projects with other people if you have a cloud account. If you don't have a cloud account, you can only store projects locally on your computer, but that works too, like all the time. Okay, come on, let me. Okay, so those are my projects. This is the one that I just saved. Like those are the ones that we all made today. And now I can share this project with you. And if you use that link, you should now be able to access my project. And let me also download it so I can add it to the link that I'm going to send to you later. So, okie dokie. So this is just like, as I said, you can if you plot static data like this, it's not very interesting. It's good, like if you're doing science, of course, then that's a very good visualization if you use axis descriptions. But since I was looking for like more artsy, more interactive ways of visualizing data, it's not super interesting if you do it with static data, but if you do it with data that changes very fast, and you can visualize that live, it's kind of cool. And by the way, what I also found out, things for some reason look better if you do them on a black background. So if you want to make the stage black, for some reason, everything looks cooler. I don't know why, but that's just the case. So you can also change the way the background looks. If you rather want to have it in a black or a different color, you can just do that from the stage object that also has costumes that we call backgrounds. Okay, cool. Maybe we do one last 5-minute break because I need to go somewhere. And then I have one final project that I really want to share with you. Maybe you just watch me program it, but it's really cool. It's a really cool way of making bar charts awesome. So let's meet again at the top of the hour, my one, your whatever hour, and short break until then. Okie dokie. So this is the last project that I wanted to do with you. And it's not actually a data visualization, but it kind of uses bar charts to do everything. So I really wanted to share it with you. So this project is Arraycaster. And Arraycaster is a way to create a 3D world in a 2D space from a 2D map. So the project that we're going to work in, wait, let me show the map and let me save it again before I show you the send you the project link. So this is the link for the last project. No, I want to send to everyone. So this is the link for the last project. And again, here I prepared a couple of sprites already, or rather Bernat did. So he came up with Bernat is my friend and colleague, and he came up with this project. And it's also, for example, how very old games, like 3D games, were constructed, like the original Wolfenstein was made with this raycasting idea. And what you can see here is two objects. One is the player sprite. So in this player sprite, we have a script that lets you move the sprite around. So when you click the green flag, you see that this script gets triggered. The sprite is set to the center of the stage, and you can now move it. So pressing the up arrow key will move it forwards. Pressing the down arrow key will move it downwards, like backwards. And then right will turn it right. And left will turn it left, and you can use that to control the sprite. Unfortunately, I'm extremely bad at gaming, so this might be easier for a couple of you. It's very hard for me, and as you can see, you can also not go through like the walls here on the map. And the second object that we have here is the map object that doesn't contain any sprites. It's just like I can hide and show it. So when you press the V key, it'll hide the map. When you press the V key again, it'll show the map and the player. So this is the only things that we have in here. And what we want to do now is we want to create a 3D world out of this 2D world. And we do that with the technique that's called raycasting. And for that, we create first a new sprite that we'll call Ray. So this Ray sprite is just supposed to be a turtle sprite. I can even call it Ray. So let me rename it. And in this Ray sprite is where we'll be working in. And by the way, because there were a couple of questions on whether you could do these projects in Scratch. So the ones that we did before, you can't do them in Scratch because you always needed like capabilities to be able to work with data, or the pasting option, like for the paste on thing that you can't do in Scratch. This project with a slight adaptation you can do in Scratch. So if you look for the Scratch website, there's a couple of Raycaster projects on Scratch too. So if you're interested in them, just skim through the Scratch website and check for raycasting. So I have seen a couple of raycasting projects on the Scratch website. Okay. So first, we want to create our ray sprite, and this ray sprite is supposed to constantly go to the position of the player and to face into the same direction as the player faces. So the first thing we want to do is when the green flag is clicked, because we start the playing thing with the green flag, so let's also start this with the green flag. When the green flag is clicked, forever, go to the player and face in the same direction as the player. So go to is a block from the motion category. Again, we used it a couple of times already. So we can either go to a random position, to the mouse pointer. We did both of these things, but we can also go to a specific object. And in this case, we want to go to the player. So if I click on that, I'm going on top of the player, but I'm not facing in the same direction. So I also want to point in direction. And then I can select either fixed directions, or I can drag in the direction of another object. And for that, I need the sensing category. And in the sensing category, I can find the off block. And I used that a couple of times before too. So for example, to find out the width of the stage. But in this case, I want to find out the direction of the player. So in the right input slots, you select the object that you want to find out stuff about. And in the left input slot, you select what you want to find out. In this case, I want to find out the direction of the player. Currently, my player is facing top right. That's direction 20. So 0 is top, and this is roughly 20. So I always want the player to point the ray to point in the direction of the player and go to the player. So whenever I move the player now, the ray will face in the same direction and go to the player. And if I do that with the green flag constantly, they'll always face into the same direction and will walk together. So this is not very interesting so far, but I'll send the links to the projects later, to all the projects. I can share the link to this project that we've currently been working in again. So this is where we're currently working in. And I'll share the links to all of the projects, or not the links, I share the project files to all of the projects later in the when we're done. Okay, so now, because it's a ray caster, we actually want to cast a ray. We have a block that does that, and it's called the ray length of 2 block, and you can find it in the distance 2 block. So in this is the 2 block, but you can find out the 2 of different things. And in this case, we want to find out the ray length to the map. Ray length means when the object shoots a ray, how long is that ray until it touches the first thing of the object that I input in here. So for example, in this case, the ray moves from here to here, and the ray length will be 86 pixels. If I turn around, it will shoot the ray into this direction. So I'm expecting a larger value because it's much longer until it reaches the first point of the map object, which is up here. So if I click here now, it's 182. If I turn around here and look into this direction, I should now get a very small value because the map is really close, the next object in the map. So now I'm only getting 16. So this is what the ray length block does. It measures if I walk in a direct line, how far is it until I touch that object at a specific position. And now we can use that to actually draw that ray. So once we did that, and once we're at the player, we want to constantly put the pen down, move the ray length forward, move the ray length back, and then put the pen up again. Or rather, we can do that by just going back to the player. So what we want to do is put the pen down, move the ray length to the map, and then put the pen up again. So this will just draw a ray. Let me move the sprite. And here you can see that I can draw the ray now in whichever direction I'm moving, but the rays don't go away again. So maybe I rather want to clear every time before I draw the ray again. So let me clear, and now I only have this one ray that I can draw. And maybe because the object is kind of distracting, let's hide the original object. So let's add a hide block right at the beginning. When we click the green flag, we want to hide the object, and we just want to cast this one ray. And you see now always what the ray length means. So in this direction that we're facing, we're casting this one ray. If you want your ray in a different color, or like the whole thing in a different color, don't worry, you can just pick whichever color you like. So if you want yours rather to be in blue, you can just reset it, and now it's in blue. Check whether there are any questions. Okay, so let me save the project so that you have my version again. If you open the link now, you'll get my version of the project. Okay, so this is not actually how our vision works. So when we look somewhere, we don't have this like one point of vision where we can look at, but we rather have a field of vision. So what we want to do now is we want to cast several rays in a field of vision. So maybe from angle -40 to 40, so that we have a field of vision that's like 80 degrees. We can do that by using a for loop. So instead of doing all of this directly in like one ray, we can do it several times in different directions. And you can find the for loop in the control category. The for loop has an internal variable that's called I, and I is automatically increased by 1 every time you loop through the thing. And that means that you can, for example, say a number. Oh, wait, we can't do that now because I'm trying. You can say a number for 1 second. So now it says 1, 2, 3, 4, 5. And when it's done, once it's reached the 10, it will stop the loop. So you can automatically loop through a whole set of numbers. And we can use that now to create a field of vision. So we can rename this variable to angle. And we can say from an angle to from -40 to 40, we always want to point into the direction of the player plus the angle. So the first line is supposed to point into the direction -40. Then the second line is supposed to point into the direction -39, -38, blah, blah, until we reach 40. So let's rebuild our script. We want to put all of that into the for loop. And now we want to point into the direction plus the angle. Okay, and now let's try this again. So what we get now, let me hide the thing again. What we get now is kind of a field of vision, but that's still very different from how we view things, because when we think of our field of vision, we don't start looking here and then start moving our head, and then we get the field from left to right, but we get it all at once. So we already found out in the last project how we can do things in like one step by wrapping the warp block around it. So what we can do now is we put the whole for loop into a warp, and now we get the whole field of vision at once. So we can now walk around and we can always see which, like here, for example, you see that you can see here, but this you can't see. So you actually have a field of vision, and you can find out where you can't see things and where you can see things. So let me save this project again. If you manage to follow along, you can try it out in yours. If not, try it out in my version. Okay, again, if you go to the project, you should now be able to check out the ray casting thing. And then there's a couple of things. Let me give you 1 minute to actually do it. And then okay, so there's a couple of things that we can change now. So for example, we probably want different colors. So for example, we want things that are closer to be in a different color than things that are farther away. And we can do that pretty easily by just creating a variable that kind of gives us the proximity to the next object. So for example, for that, we can create 2 variables. One we'll just call the length, and this is going to be our ray length. So instead of just using the actual ray length in here, I'll set the length to the ray length, and then I'll use the length in here. So if I start this again, it won't change anything. This is still the exact same project. But now I can use this length variable that I made to kind of create a value that gives me the proximity. So that should be something that's proportional to the ray length. and I'm making a variable for that. And let me call this variable proximity. And let me set this proximity to some value divided by the length. And we tried it out and we found out that 2000 is a value that works quite well. So we divide 2000 by the length that we have. And now we can use that as an input to the pen brightness. So then we want like values. Let me just do it first. I want to set the pen brightness to the proximity value that I have. And if we do that, we see that things that are farther away are black or darker, and things that are closer are brighter in this bright blue color. So that means we can now represent closeness or proximity with the color. So this is already pretty cool. But as I said, what I actually want to do is a bar chart thing. So let me save this again. And now let's try to make this into a bar chart instead of our field of vision thing. So to get the bar chart, what we want to do is we want to actually still draw these same rays, but instead of drawing them in a field of vision going out of the tip of our player sprite, we want them to be like histograms, like bar charts from the left of the stage to the right of the stage. And here, for example, the left ones are really short. So I want really short ones here on the left side, and I want really large ones here in the middle, and then I want the super large ones here on the right. So we can now just represent what we have as a field of vision as a bar chart histogram thing from left to right. So to do that, we can go to the right position, and we can always find the right position because we already know that we need 81 lines here because of our for loop. We have 80 rays in here. So we always go to the angle divided by 80 times the width of the stage. Times the width of the stage. The width of the stage is again the off block. And we want the width of the stage. So this will give us the right position for each of the histograms, each of the bars that we want in our bar chart. And if we do it like that, you can see that now instead of having them shoot out of the ray, I'm having them as a histogram from left to right on the stage. What's different, like in a histogram, usually all lines are just facing upwards in direction 0. Mine are facing into the direction that the sprite is currently facing, so that's kind of off. So let's change that by just pointing in direction 0 before we draw them. So now they're all facing upwards. And then the next thing that we want to do is also maybe in a histogram, I think that's actually a definition of a histogram, that all the bars touch each other. So we want to increase the size of each line that we're drawing. So we want to set the pen size to something differently. And the size, we already did that a couple of times now. So the size of the pen is just the width of the stage divided by the number of lines that we have. So we can just set the pen size, and we can do that right at the beginning because we know that we'll always have 80 bars. So we want the width of the stage divided by 80. And again, let me just copy the width of the stage from here. So this is now our bar chart. What we notice now is that it's kind of off because, let me save it again so you can try it out. But what's kind of off is the closer we get to the wall, the smaller it gets. And that's not how our vision works. So if we are very close to something, it's usually very big. And if we're really far away, like from perspective, it looks very tiny. So we kind of need to inverse this now. We can fix that pretty easily because we already have like an inversion of things, and it's that proximity. So instead of moving the length, we can just move the proximity. So let's try that. And now we see that we can move closer to a wall and it gets bigger. And if we move farther away, it gets smaller. So that's already pretty good. But there's like, you might notice one more thing where our wall starts at the bottom of the wall is 0, and it's always y0. But this is also not how our perspective works. So usually we perceive things in a more that they are more centered around the like central line. So maybe we want to center all the bars that we have by just moving them downwards half of their length. So we can do that easily. We know what the length is. The length is the proximity. So we can just move them down or transpose them down by half of the proximity. So we just divide the proximity by -2. And then we'll do this again. So now it's centered around the middle. And we can now hide the map to actually walk through our maze that we made just out of bar charts. So let me save this again and let me give you a chance to try it out. If somebody joined later, here's again one last time the link where you can try things out. And again, if you want to try this out, just click on it. If you want to change the color, you can just pick another color here. So if you want yours rather to be pink now, you can just switch the color and it can be pink or yellow or whatever, whichever color you want. Okay, there's one last thing before we're done with this project and with this workshop. You see that when you walk really closely to a wall that you get like this fisheye effect thing. So when I'm close here, not all the walls have the same, like they don't end at the same spot, but they rather have this fisheye effect. This is because, let me show this to you. Okay, this is because we need to apply some trigonometry, because what we actually did with the field of vision is we cast rays, but the ones that we cast into this direction are much longer than the ones that we cast in the center. And this results in, let me switch to the next costume. This is like, so, and now we plotted these lines just from left to right, and this results in this fisheye thing that we're seeing. So we're using the inverse value. That's why our fisheye is in the other direction. But we're basically pretending that the walls are differently far away, but that's just because we did this field of vision thing. So the fisheye that we see is kind of the opposite of this one. And what we actually want to calculate is this distance. But what we're using right now is this distance. So we can get rid of that fisheye effect by just using the cosine and then applying it to all our lines. By using the cosine of, if you use the cosine of the angle, we're taking care that the ones that have a higher, or that angles, well, where the angle is farther away from the original direction of the player, those get adjusted more than the ones in the center. And by that, we can get rid of the fisheye effect. So let me hide this again. And let's go back to the ray and let's do the one last thing, because what we need to do to get rid of the fisheye effect is, instead of taking just the ray length, we need to take the cosine of the angle times the ray length. So let me grab a cosine block, and we want the cosine of our angle times the ray length to the map. Okay, so now you can see when you move closely to a wall that it's more like a line and not like this fisheye thing. And again, if you want to see let me hide these variables. If you want to see where you are on the map, you can press the V key, and that will show you where you are. And then if you press the V key again, you can hide the map. Okay, good. Then let me save this last project. And let me go through the, can you provide material? Thanks. Okay, good. So I prepared a couple of materials that are in this Google Drive. Let me try to get the link again. There's a couple of things that I have and a couple of things that I don't have. Okay, let me get the link. Hello. Hey, come on, link kopieren. Okay, so this is the link to all the resources. I put them in different folders. So the folder for the timelines, that's the first project that we did, actually contains a PDF document that guides you through all the projects. And then there's the starter project that we started with. And then there's the solution project. And then there's even an advanced project that uses more images and uses an offset. Those are not links. Those are XML files. So if you want to check out the projects in Snap, you need to download them. So you click on the link, download the project. Usually it lets you know that XML files are potentially dangerous. Those are Snap projects, so they aren't. But please, if you download XML files from other websites, make sure that they are okay. And then if you are in Snap, like you need to go to the Snap website, that's snap.berkeley.edu. And then in the Snap website, you can just drag the project in, or if you feel uncomfortable with dragging or don't have a device that allows dragging, then you can click on the file menu, select import, and then look for your project and open it. So this is the solution project of the advanced thing, but this works for all of the projects. So in the timelines thing, there's a description, PDF description that explains everything, and then 3 solution projects. In the population by pixel, you have a starter project, the one that we use, that also has the exercises and a solution project. And I added 2 documents, and where I just showed the, this is the link to the original project, and this is the link to the IUCN website that you know where I gathered the data. In the CO2 on your birthday project, it's the same. So I added a list with, I added a document with a link to the Keeling curve thing. And, oh, I added the starter project, but not the final one. Okay, let me fix that right now. So I'm adding the final project too. Download. And then in the last one, the Raycaster, I also just have 2 projects. I don't have a description or anything for the Raycaster. I always wanted to actually make one, but I never managed. And I don't want to promise that I'll do it this week. So which one was the original one? Okay. Okay, now I don't know which one was the original one, but one is the solution, one is the starter project. And then for the Raycaster, I really just have the 2 projects. So it's the starter project and the one that we just built. I added them both, but there's like no additional description. And then the last thing is the microphone visualizer that I just added. If you're interested in a description, I think I have one for this project, then I can upload it here too, but I need to find this one first. Okay, let me check once more for the questions. Okay, I think we're all good. And then thanks for participating. And I think I'm now allowed to give you the code. It's this one. And I'm glad that you joined. Again, if you're interested in the courses, and if somebody's interested in yesterday's resources because I think someone has asked. So this is the Google Drive to yesterday's workshop about the Snap GPT thing. There's also a solution project inside and a starter project. So, and a paper that explains everything. So if you're interested in that, feel free to check this out too. Okay, then thanks for participating, and maybe I'll see you in another workshop.
Iadka, can I close the session?
Yep. Thanks,
All right.
Engen.
All right. All right. Thank you.